This is section 175. We're going to continue on looking at transformations in basic graphs. In this lesson, we're going to apply scaling transformations to the graph. Now, we looked at non-rigid transformations, or rigid transformations, where it moved left or right and there was a level of reflection involved. Now, with non-rigid transformations, they distort the shape of the graph by stretching or shrinking the graph. And it could be stretched vertically, or it could be stretched or shrink horizontally. So there's two ways to apply this stretching and shrinking. And the best way to kind of think about it is it's like a rubber band. If you were to pull on the rubber band, that's stretching. If you were to push on the rubber band, that's shrinking. If you were to pull on the rubber band, that's stretching. And if you were to push on the rubber band, that's shrinking. So whenever there's a number in front of your function, we're going to call that number c. If it's ever greater than 1, we would say it's vertically stretching. If it's between 0 and 1, that's going to be a vertical shrink. Now you might be thinking, well, what happens if c is negative? That negative is separate. That negative tells us the reflection, which was what was going on in the previous lesson. And if we are multiplying our x by a number, that affects the horizontal, and it's opposite. So if it's greater than 1, we call that a horizontal shrink. And if it's between 0 and 1, we call that a horizontal stretch. Now, it's important to note that the rigid transformations, which were the shifts and the reflections, changed the position of the graph. The non-rigid transformations, it changes the shape of the graph. And we can kind of take a look at an example here in a moment. But for this one here, this x minus 4 squared plus 3, we could say that it shifts 4 spaces to the right and 3 spaces up. It actually takes the shape and just moves it up or down, left or right. But if I have this 3 in front of the x, I know that it's going to give it a nice little horizontal compression, right? And that essentially it made the graph change its shape, but the position didn't move at all. So let's look at a few examples. So if I have f of x equals x squared, x minus 3 squared, it moves the position, but the shape is the same. Now if I put a 3 in front, that's a vertical stretch. Notice the shape is different. Now I know you're thinking, well, they're both parabolas. Yeah, they're both parabolas. But what I'm talking about is even if you were to do like up 1 over 1, you know, like this position, the way that those are oriented, that's not the same. Right? And imagine like if this was like a rubber band and you pulled on it, that's why it looks like it kind of went in a little bit. Just like if you pull the rubber band, it moves in. If I wanted to look at one where it's greater than 1, like 5x, right, it's going to stretch vertically. And then if it's between 0 and 1, imagine you're pushing down. If that was a rubber band and you push down on that rubber band is going to kind of like widen a little bit. And so if it's between 0 and 1, we get that horizontal shrink. Vertical. Let's look at the horizontal. If it's 5x, so it's greater than 1, that's going to be our shrink. Imagine I pushed in horizontally. And then if it's between 0 and 1, if I pulled, right, that's the stretching part, and that's why it widens. So let's look at a few of these. So we still apply any reflection. So I have a negative, so I know it's going to reflect over the x. I have a horizontal shift of -2 and a vertical shift of -1. So my shape So apply the reflection. And then from there, we're going to do the movement. So it's going to move over 2 spaces and down 1. So now normally it's going to have that type of shape. But because of that 2, that is a vertical stretch. And so it gets pulled more than normal. Now you can plug in values to kind of get it exact, but we're just more looking at the fact that it distorted. And so you just draw in the original with the stretch, and you know that you're basically signifying it has that vertical stretch. So for this one, negative 1/4 x plus 3 cubed. So I know that that's going to be my cubic function. Reflection over the x. Here we are going to have a vertical shrink. We have a horizontal shift of -3 and a vertical shift of -1. So I have the reflection, so that's going to go down and that's going to go up. And then it's going to move over 3 spaces and down 1. And so this is the original. Right, so that's the original. But then we said that this is a vertical shrink. So imagine if this graph got pushed. And so if it did, it would look a little kind of like it got pushed down. It makes it look a little wider per se. So closing today's lesson, what did we learn? We talked about the vertical and horizontal shrinking and stretching of our graphs. So what type of transformation should be formatted first? This is going to be a pre-calc topic, but when you have a horizontal stretch or shrink, you have to format it, but we're not going to go over that in this class. And then what's the difference between this letter in front of our function versus this letter inside of our function? This is the vertical stretch or shrinking. And this B right here, this is the horizontal stretch and shrinking. This does conclude our lesson. If you have any other questions, please leave them in the comments.